In the last class we have seen the definition of drift velocity and electric current. In today's class we will derive an equation which will give us the relation between current density and drift velocity. So we will take down a question and we'll try to answer it. So when we answer that question, we'll give the relation, we will get the relation between current density and drift velocity. First take down this question. Derive an expression for the current density of a conductor in terms of the drift speed of electrons. In terms of the drift speed of electrons. So derive an expression for the current density in terms of the drift speed of electrons. So for this I'll write here solution. Let us say how we can do this. This is basically a derivation. So now for this we will consider a conductor of length L. Consider a conductor of length L and we apply an electric field E by connecting this conductor to a battery. Connect the conductor of length L to a battery. So let the length is L and area of cross section of this conductor is A. So we'll have electrons with drift velocity Vd. The electrons will flow in this direction. The electrons. So the applied electric field is in the opposite direction, E. So let L is the length of the conductor, A is the area of cross section of the conductor. So we are considering a conductor of length L and area of cross section A, and we are applying an electric field E by connecting it to a battery. So let so we'll write let L is the length of the conductor. A is the area of cross section of the conductor, and then let N is the number of electrons per volume. Or I can call it as number density, and E is the charge of an electron. E is the electron charge of an electron. So let potential difference V is applied. So let me say this is V and a current I flows. So this is the direction of conventional current, whereas electron flow is in the opposite direction. next you write let potential difference V is applied across the conductor of length L. Let potential difference V is applied across the conductor. The electric field E produced inside the conductor is given by then the electric field E produced inside the conductor is given by is E equal to, so this is will be given by V by L is V divided by L. Now we need to find out the current. So current to the conductor is given by, our first aim is to find out current density. First we will find out what is the current. So current through the conductor is given by I is equal to Q divided by T. This is definition of current. Now I'll find out what is the charge on the conductor and what is the time. So total charge Q is the number of electrons multiplied by electron charge. So first we will find out what is the number of electrons present inside the conductor L. So number of free electrons present in L length of conductor is given by number of free electrons present in L length of conductor is given by, so number we have assumed N is the number per volume, so N into volume, that is A into L, area into length, NaL. Therefore total number of free electrons, total charge contained in length L is Q is equal to E into, that is charge of an electron, into number of electrons, NaL. So we got Q. Now we will find out what is T. So if Vd is the drift speed of electron, so let Vd is the drift speed of electron or drift velocity. Vd is the drift speed of electrons. Then time taken by free electrons, time taken by free electrons to cross the L length of conductor. Conductor is T is L divided by Vd. L divided by Vd, because velocity is distance by time. So using that equation we get time is L by Vd, basic equation. Now let us substitute these values in the current. So Q, let us take this equation as equation 1 and this is equation 2. So substitute equation 1 and 2 in equation of current. Substitute equation 1 and equation 2 in equation, let me mark this equation as A. So let us consider this as equation A. So now we will get I is equal to Q is E into NAL divided by L by Vd. L divided by Vd. So now simplify this. L will get cancelled. So we have L and L will get cancelled. So we can rewrite this equation as I is equal to N into E into A into Vd. Now current density is I by A. Current density is J equal to, it's I by A. So J, current density, is equal to N into E into Vd. This is the relation between current density and drift speed of electron. So we can write, thus current density of conductor is proportional to drift speed. Thus current density is proportional to drift speed. Current density is proportional to drift speed. Current density is proportional to drift speed.